Okay, let's be honest. Bread, pasta, potatoes, cake, we all have a favorite carb, right? They're the go-to comfort food, a huge source of our energy. But behind these foods we absolutely love, there's this fascinating chemical story that, and I'm not kidding, shapes our entire world in ways you probably never, ever expected. So let's dive in and see what's really going on inside our favorite foods.
So, before we get to the really wild stuff, we've got to cover the basics. What exactly is a carbohydrate, and where in the world do they all come from in the first place? I think this little guy, yeah, he speaks for all of us on some days. We crave them, we eat them, but what is a carb, really, when you get right down to it? Well, turns out the answer is hiding in plain sight. The secret is literally in the name. A carbohydrate is just made of carbon, that's the carbo part, and then hydrogen and oxygen, which are in the exact same 2-to-1 ratio as water. H2O. That's where hydrate comes from. So it's just carbon plus water. That's it. That is the basic recipe for every single carbohydrate on the planet. Okay, so if carbs are just carbon, hydrogen, and oxygen, where does the very first one come from? You know, the original? Well, this story doesn't start in a bakery or a kitchen. It starts inside a leaf. Every single carb you have ever eaten owes its existence to this one magical process: photosynthesis. Plants are just incredible little chemists. They literally pull carbon dioxide out of the air, suck water up from the ground, and then use the energy from sunlight to smash them together into a brand new molecule. And that first original carbohydrate, it's called glucose. And everything, I mean everything, starts with glucose. The best way to think about it is like, it's the ultimate Lego brick. Nature uses this one simple sugar molecule to build all the other way more complex carbohydrates that we're about to see. From the sugar you stir into your coffee to the wood that makes up your table, it all traces back to this one tiny molecule made from sunlight. All right, so now that we have our fundamental Lego brick, let's see how nature actually builds with it. Carbohydrates are basically organized into families, and it's all based on how many of these little sugar bricks are linked together. So here's how it all breaks down. Carbs are basically put into 3 groups based on their size. On one end, you've got the monosaccharides, mono meaning one. Those are the single sugar units. And all the way at the other end are the polysaccharides, poly for many, which are these giant long chains. We're going to focus on these 2 main groups to see how they build, well, everything. Let's start with the simple guys, the monosaccharides. So besides our main hero, glucose, this family includes fructose, which you get from fruit, and galactose from milk. And get this, 2 other simple sugars, ribose and deoxyribose, literally form the backbone of our genetic code in RNA and DNA. How wild is that? And you can really see what we mean when you look at them here. They're so simple. Each one is a single, self-contained unit. Sure, they might have slightly different arrangements of atoms, but they're all individual molecules, ready to be burned for energy or, way more exciting, to be linked together to build something much, much bigger. And that is where things get really cool. When nature starts linking hundreds or even thousands of those glucose bricks together, you get the polysaccharides. These are the heavyweights, the giants of the carbohydrate world. Now, the 3 most famous polysaccharides are starch, glycogen, and cellulose. And what is absolutely mind-blowing is that they are all made from the exact same brick, glucose. The only difference is how those bricks are snapped together. And that one tiny difference, it changes everything. First up, starch. This is how plants store energy for a rainy day, packing it away in things like potatoes and rice. Starch is really just a long chain of glucose, and it comes in 2 flavors, a simple straight line called amylose, or a kind of branched out structure called amylopectin. Now this is our version of starch. It's called glycogen, and it's how we animals store glucose in our muscles and our liver. Notice how it's way, way more branched than starch? That's totally by design. All those branches give our body tons of places to attack and quickly clip off glucose molecules when we need a sudden burst of energy. It's brilliant. And finally, we have cellulose. And again, it's just a chain of glucose, but here, the links between the bricks are a little different. And that allows the chains to line up perfectly and form these incredibly strong, rigid sheets. This is what gives plants their structure. It's the fiber in your vegetables, the wood in trees, and the cotton in your t-shirt. It's super strong, super tough, and for us, totally indigestible. Okay, so we've gone from a little bit of sunlight to simple sugar, then to the starches we eat and the fiber that builds the entire plant kingdom. But the story doesn't end on our dinner plate. Oh no, not even close.
I mean, that seems to be the logical conclusion, doesn't it? Carbs are for energy, and they're for building plants. Simple. But what if I told you that you've been using complex carbohydrates all day long in ways you've never, ever imagined?
Yeah, the real answer is they're in almost everything. You know that creamy texture in ice cream? That's thickened with polysaccharides. The reason your paint doesn't just drip right down the wall? Polysaccharides. They're in cosmetics, detergents, paper, even your pet's food. Those same giant carbohydrate molecules are absolutely essential for giving these products their texture, their stability, and their structure.
Just stop and think about that for a second. The very same starch that gives a potato its dense texture is used to thicken paints. The same cellulose that gives a tree its incredible strength is used to make the clothes we wear and the paper we write on. These molecules are some of the most versatile and useful building blocks on the entire planet.
So the next time you look at a piece of bread or a potato, just remember that its main ingredient, starch, is part of this massive family of molecules that not only fuels our bodies, but is also used to literally build the world all around us. They're a renewable and incredibly versatile resource, which really makes you wonder, what else can we build with them? What are we going to do with them next?